Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today, we will look at the monitoring and conditional deletion of archive or log files. When writing applications, there comes a time to write out to log or archive files, especially if the application you're writing is a background task that is not monitored by a user. Many of these log files will be overwritten each time the application runs. However, there will be some archive files which you wish to keep for days or even weeks. These files are usually named containing the date and possibly the time. Over time, the number of these archive files can actually build up, and you'll need to do a bit of housekeeping to clean out the old files. What we're going to look at today is a routine which can be called periodically to clean out files older than a certain time. We're going to create these new routines in a new library file called PB Archive Files, and we're going to include this into our application here. This new library file will contain all the routines needed to archive your files. In order to perform the function of archiving or deleting of these files, we'll need to know what folder actually contains them. So in order to demonstrate this application running, I've created a few files. We have in this archive folder a number of files with the extension log, and a number of files with the extension txt. For these files, our plan is to delete files older than 30 days. If we have a look at one of these files, and do our properties, we'll see that there are in fact 3 dates kept for this file. A date which the file was created, a date which the file was last modified, and a date the file was last accessed. As these files have been copied from somewhere else, the creation date is more recent than the modified date. The modified date is the date the file was last written to. And we're going to be using the modified date to determine whether the file is a candidate for deletion or not. Some of these files date back to 2019, and some of these files are this year's files. So in order to perform this deletion, we first need to know the name and path to the folder that contains the files. Next, we will want to know what type of action we wish to do on the file. For this type of program, you may want to actually just log the files that could be deleted before you actually do the deletion. So we're going to have 2 types of action in this program. One to delete the files and also log the ones it has deleted, or just to log the files. So we will initially set this up just to log files that could be deleted. Next, we'll need to tell the application where we want to create the archive log. This will be the list of the files that actually could be deleted or the files that have been deleted. Our next thing to tell the application is how to determine which files to actually work on, what the wildcard is going to be. In this case, we're looking for all files who have the extension txt. This being a wildcard can of course be amended in a number of ways. You can look for any extension or anything before the extension, perhaps all files starting with a particular letter or name. We're going to set this program up so it can delete files more than 30 days old, or 30 minutes old, or 30 hours old. So we'll need to designate the time period and the number of units. So this will allow us to tell the application we're working in days, and the number of days we're interested in is 30. So any file that was last modified more than 30 days ago will become a candidate for either logging or deletion. And we're going to create one function whose job it is to take these parameters and to perform the task in hand. This function will be called archive files. This will take the parameters of the folder, the action, the log file, the wildcard, the time period, the number of units, and additionally a variable which will contain an error should one occur. So now we need to move to our library to create this new function. The function will take in all the parameters we have previously mentioned. We're going to be storing the data for each of the files in our target folder as a user-defined type in an array. The user-defined type we're using is one which is inbuilt to PowerBasic. It's called dir data. As you'll see from the help file, it's one of the built-in user-defined types. It contains a number of pieces of information which are very useful, and the one we're most interested in is the last write time. It also contains the file name and information on the file attributes, all of which we can use. Before we start working out which files need to be deleted or logged, we need to check the parameters that have been passed in from the calling application to ensure that all the parameters are indeed valid. So first of all, we will trim off any trailing backslash on the name and path to the folder. Next, we will check to see if the folder actually exists. We can do that using the isFolder function. If that returns false, we can populate our error variable and exit the function immediately. Next, we want to check the action. Does the user want to log or to delete files? If the user wishes to do anything other than either log or delete, we will return an error immediately and exit the function. Additionally, we will check to make sure that the log file is not blank. Next, we will check to ensure that the wildcard variable has indeed been populated. Next, we will test the time period. Has the user entered days, minutes, or hours? If anything else has been entered, we will exit straight away. If we get to this point, then all inputs have now been validated, and we can now start to scan our folder. So in order to do that, we're going to create a new function called scanFolder. The information this new function is going to need is the name and path of the folder to scan, the wildcard we're looking for, and passing the pointer to the array which will contain our file data. And taking back from that function will be an error variable should one occur. We'll create this function in a moment, but we'll push on inside this function to complete it. The scanFolder function will return true or false. If everything goes well, it will return true to say that the str files array now contains a list of all the files contained within that folder, which happen to match the wildcard. So our next task is to check the date and time last modified on each of these files. And we're going to create another new function to trim the file list. Again, this function will return a true or a false. The function will have removed any file which is newer than the date or time we're actually looking for. So what's left in the array is a list of files that can either be just logged or logged and deleted. So our final function is to perform the logging or deleting. And we're passing this new log or delete function a number of parameters. We need to pass it the array containing the list of files. We need to pass it the folder in which these files are contained. We need to pass it the action to say whether we're logging or deleting. We need to pass it the log file so it can update that file. We need to give it the time period, the days, hours or minutes, and we need to pass it the number of units. Is it perhaps 30 days? And finally, the error variable, which will be passed back to the calling routine should an error occur. So having created the archive files function, we now have to create these new subfunctions. Let's start first with the scanFolder function. As the name suggests, this is the function which will be scanning the folder of our choice, using the wildcard and populating the array. Within this function, we're going to be using the dir command. The dir command can be used, as you can see, to pass information to our array directly. However, we're going to be running in a while loop. At the moment, we have not yet dimensioned the size of our array. As we don't know how many files are going to exist within this folder that will match our criteria, we don't know how big to make the array. We're going to redimension the array initially at a set size. And then once we find a file which would mean the array needs to be extended, we will extend the array in a block. So we'll need some local variables to help us keep track of all of this. So we'll want a file name variable to hold the name of the file. We're going to be stepping through using a counter long R. And I'm going to use a long max array to measure the size of the current array. So we're redimming str files from 1 to a constant size. This is array block. You can set array block to be as big or as small as you need. So what I'm going to set this at initially is a size of 500, So when we first dimension our array, it's going to have 500 elements. This may be more than enough than you actually need. However, if you have a folder that contains more than 500 files, we'll need to increase the size of the array accordingly. So in our while block, we're actually testing the length of the file name. If the length of the file name is greater than an empty length string, then we will drop into the while block. Our first task is to increment the pointer long R. This will point at the next element in the array that we wish to populate. If long R is greater than the current maximum array size, we can then redimension our array to make it bigger. We do this by adding the size of our array block to the maximum size that already exists. So if it exceeds 500, it will redimension the array as being 500 greater than that. So the array will then be 1000 in size. Keeping the block size reasonably large means you don't have to do this very often, and therefore makes your application more performant. The last line in our while block is to get the next file, and it will populate into the str files array. And this will continue until we have stored the names of all the files in our array. We can then return a true to the calling function. So having completed this function, we now go on to the next one to do. This is the one that trims the file list. It will step through the array and remove any file that does not match the time period we're looking for. This takes in the necessary parameters. And we're creating some local variables, a couple of PowerTime variables, a blank variable containing dir data, a row counter, long R, and 2 additional variables for calc units and 1 for the sign. First thing we will do is populate the blank value. This variable is used to replace data within the array for files we're not interested in. Next, we want to populate our 2 variables, which are going to be PowerTime variables. One of these is going to contain today's date and time, and the second one is going to contain the date and time of the last time a file was actually written to. We can pick up today's date by using the now method. Next, we want to step through the array one record at a time. For each record in the array, we want to pick up the last write time from the file details held in the array. We're taking that information and putting it into the file time part of our PowerTime variable for the file. As there are 3 ways of looking at this, we need to look at the time period next. Are we looking for minutes, hours, or days? And we're going to use a select statement to do that. If the time period we're looking for is minutes, we're going to use timediff. Timediff is a PowerTime command to allow you to pick up the time difference between 2 PowerTime variables. There are 3 variables we can slot in here. We're using byval0 for the days and hours, and we're picking up the number of minutes in the calc units variable. If we're doing hours, the calc units is in the second last variable, and for days, it's in the third last variable. Therefore, the calculated units will return either minutes, hours, or days. Before we test to see if this number is in the range we're looking for, one additional check I want to put in here. The long sign variable will return either a 0 or a -1. If the value in long sign is -1, it means we have detected a future date. In other words, the last write time of the file is sometime in the future, beyond today. While this is highly unlikely, you never know, and it's a good one to test for. This would quite easily pick up rogue data on files where perhaps the server or desktop machine had an incorrect date and time on it. If we get past that, we can now test the value in the calc units variable. Is it less than or equal to the units? If that is the case, then the file is not to be logged or deleted, and we can populate the element of the array with the blank value. So in other words, if we're looking for something which is 30 days old, and the calc units returns, say 5 days, then it is a newer file than we're interested in, so we would keep that file. And at the end of that function, we're returning true. So now that we have deleted from our array any file which is not to be logged or deleted, we can now create the final function, the one that actually performs the logging or deletion of a file. This, as you will expect, will need to take in all the parameters. So as you would expect, we're going to do another for next loop in here. But first we want to open our log file. If we are just logging, we'll be writing to this file. If we're deleting, we'll be logging to the file as well, but marking the files as deleted. So we're writing into our log file a list of files in the folder the user has specified. And the second line says which are older than, for example, 30 days. So now we'll do our for next loop. So we're picking up the file name from the array and the file name property. As the file name property is a fixed length string, we're using the trim $ command to take away any trailing spaces. We can then test to see if the file name is not blank. If the file name is not blank, then it's a valid file. It's one we have to do something with. So we now have to look at our action variable. Are we just writing to the log file, or are we writing to the log file and attempting to kill the file? So we can quite easily do that using a select case statement. If it's log, then we just print the file name to the file. If we want to delete the file, then we are in another try-catch block. We attempt to kill the file based on the folder and the file name. If that's successful, we can print deleted on the log. If for some reason that has not been successful, then we can print unable to delete to our log file. We're tacking on to the end of this line the error $ variable. This will automatically contain whatever the error was that PowerBasic has encountered when it's attempted to delete the file. And at the end of the function, we can close off the file. So this should complete all the code in our library. If we go back to our main code file now, there are a few variables right at the beginning we'll need to create. These are basically all the variables we're going to be passing to the functions. So having created these, let's try compiling the application. And our application compiles quite cleanly. Before we run the application again, let's look at the target folder, the archive folder. As you can see, this folder contains two types of files. It has files with a log extension and files with a txt extension. In our code, we're looking specifically at files with the txt extension. And at the moment, we're looking for any file which is older than 30 days. So quite a number of these files should be deleted. So we'll run the application first of all just to log the files that it could delete. So if we double click on our exe, the application has run, and we now have an archive log.txt file. If we open that up, we'll see there are a number of files which are showing as being older than 30 days. If we have a look in the archive folder, all the files are still there, but the ones you would expect, for example list.txt, if we have a look at that file and look at the properties, we'll see it was modified last in 2020, so it was obviously more than 30 days old. If we look at one of the files that's more recent, for example this one here, it was created on the 28th of February. So timeline 1 should not appear on our list, and it doesn't. So our function to return the files which are older than 30 days appears to be working. So let's try running the delete option now. So we've changed the action in our application to delete. If we compile that and run the application again, it has created a new archive log, and in it, it's showing all the files are now deleted. So if we go into the archive folder, we'll see there are now far fewer files in it, and it has only kept two text files. One which was last modified at the end of January, and one which was modified at the end of February. So let's put all those files back in again and attempt to see if we can get any errors. Right, all our files have now been put back in. Now we know that the list.txt was one of the files which it deleted. So if we amend the properties of that to make the file read-only. If we run our application again, it runs, it creates an archive log file. If we look at that, we've now got a message for list.txt to say it was unable to delete, permission denied. So any file which has been marked as read-only will not be deleted, and it will give you the error to say why it could not delete that file. If you have a need to change the properties of the file before deletion, we could also do this, but that's something we'll possibly leave to another video. Hopefully you'll find these routines useful in your applications, but that's it for today. Thank you for watching.